Hello everyone, I'm back with a new video on performance optimization part 2. In the previous video, we explored how to troubleshoot performance issues in application. If you missed it, don't worry, I've included the link to part 1 in the description below. So today we are diving into the next crucial step, how to optimize the performance of a microservice application. So let's get started. So let's divide this optimization strategy into three parts: infrastructure optimization, database optimization, and code and algorithm optimization. So the first thing which we can do to optimize our infrastructure is to deploy microservices in containers, example Docker, to isolate resources and ensure consistent environment. So what does containers do? Containers only include the application and its dependency, making them much lighter than virtual machines. Next thing is, if you have a global application, then we can use the content delivery networks, which reduces latency. So CDNs, content delivery networks, have servers distributed globally to serve content from the location nearest to the user. So it reduces latency. So in order to make your application very efficient, we need to distribute the traffics evenly. For that, we can use the load balancer. So we can use the internal load balancer. One example is Kubernetes services for even traffic distribution. We can use an API gateway, which acts as an entry point to the system of microservices or API. And what does API gateway do? It is used for centralized routing, authentication, and rate limiting. Rate limiting means to control the rate of incoming requests to prevent overloading backend services. Another thing which we can do is traffic shaping. That is to managing traffic during updates. We can do it by implementing either blue-green deployment or canary releases. Now, what is canary deployment? You need Canary deployment mean to deploy a small percentage of new version to test stability before rolling out fully. And blue-green deployment meaning to maintain two environment, one for production, the blue one, and green for staging, for smooth transition. So it's an deployment strategy used in Kubernetes to ensure seamless and reliable update to application with zero downtime. At any time, only one environment serves live traffic. After deploying the new version, that is the green one, traffic switches from blue to green when the new version is verified. Next is scaling. Now, during sale such as Black Friday, what happened? A single instance is not enough to serve all the requests. So we need to automatically adjust the number of server in response to changing workloads or traffic demand to ensure that our application have enough resources to maintain performance. So the scaling is of two types: horizontal pod scaling, automatically scale services based on CPU, memory usage, or custom metric like request count. We need to set some threshold that if our CPU or memory usage reach certain threshold, then we need to auto scale our containers. Another is vertical scaling, which means optimizing service performance by adjusting containers resource limit dynamically. A microservice needs to communicate with each other. So we should prefer asynchronous communication over synchronous communication. We can use message brokers like Kafka and RabbitMQ to decouple services and enable asynchronous processing. When we are using an asynchronous communication, a services becomes independent and can operate without directly interacting in real time, and requests are queued and processed later, preventing system from being overloaded. So it optimizes up the performance of our microservices. Other infrastructure related optimization is network optimization using HTTP or gRPC for faster and more efficient communication. And we need to always monitor our application. We can use Prometheus and Grafana for real-time metrics like latency, error rates, and throughput. We can set alerts and then we can do the modification if there is any alert, and we can implement distributed tracing. One example is Zipkins to trace request path across microservices. So if there is any issue, we can debug the communication between microservices. We can use service discovery tool like Eureka to locate services. It helps optimize performance by efficiently managing the discovery and communication between services, ensuring scalability, reliability, and minimal downtime. For deployment, we can use CI/CD pipeline. We can use tools like Jenkins or GitHub for efficient build and deployment pipelines. These infrastructure related optimization strategy improve the microservice application's performance significantly. Next is database optimization. First thing is we should ensure each microservice has its own database to prevent cross-service dependency. We can use indexes in a table. Indexes help speed up data retrieval by allowing the database to find rows without scanning the entire table. And if you have slow query, then we can use a query optimization strategy. We should avoid select star. Instead, we should explicitly mention columns which we want to fetch. And you can use join instead of inner query because join is more faster. Reusing of database connection instead of creating new connection every time to reduce overhead from repeated opening and closing connection. Other thing is we can use database partitioning. What is partitioning? Splitting a large table into smaller manageable pieces to improve performance. Now there are two types of partitioning: horizontal partitioning, that is dividing rows into smaller table based on a range or hash. Then we have vertical partitioning, which is means separating columns into different table. Partitioning speeds up the database access. Other thing we can do is sharding. What is sharding? It distribute data across multiple database to handle massive data volumes. Like suppose you want to shard an order database by user ID, then user with ID is 1 to 1000, one data you can create one database called DB1, order DB1, and from 1001 to 2000 another database called orders DB2. So if you want to access suppose 1500 database, it will go to DB2. It won't scan the entire table. So by distributing this data across multiple shards, the system can handle large data set and higher loads, and adding new shards allow the database to scale horizontally, accommodating growth in traffic and data size. And queries are directed to specific shards, and it speeds up the performance of query. Next is we can use the CQRS pattern. What does CQRS stand for? Command Query Responsibility Segregation. This can significantly optimize database performance in a microservice architecture by separating read and write operation. CQRS divide database operation into two distinct models. Command model handles write operation, example create, update, and delete operation, and query model that handles read operation. That means fetching of data. Now, by separating these operations, we can optimize data model independently for reads and write. Uh, the read and write scales independently. So if you have a lot of read operation, you can scale the query model more, and you can use a specialized database for each operation. Like if you have transaction related operations, the database which deal with write operation, you can use MySQL. And if you have a lot of read operations, then we can use some NoSQL database like MongoDB and Elasticsearch to optimize for high speed queries. Other thing which can we do is code and algorithm optimization. We can use in-memory caches like Redis or meme cache for frequently accessed data. In-memory cache have low latency, so it is more faster. We can use string builder instead of string for concatenation purpose. If you have to create a lot of string, then use string builder where you do not need to create new object. But if you are using string, every time a new object would be created, which will takes a lot of memory. Use synchronization only when necessary, or use locking or some lock-free data structure like concurrent hash map. In order to avoid memory leak, you need to close resources like stream, connection, and file using try with resources. And other thing you can do is set JVM options for efficient memory and garbage collection. So we have covered three strategies to optimize the performance of microservice application. Remember, performance optimization isn't a one-time task. It's an ongoing process that involves constant monitoring, tuning, and adapting to evolving requirements. So if you found this video helpful, don't forget to like, share, and subscribe. Also check out part 1 of this series for tips on troubleshooting performance issues. Link in the description. Thanks for watching, and I'll see you in the next video.